So a little bit about myself. I was a frequent visitor of Ajug, and I was talking to a couple of folks previously, Roy and other folks. And around 2001 to 2008 was my peak time when I was coming to Ajug. Ajug was there in Ravinia. Okay, as I was telling you guys my story, Ajug plays a special part in my life. I was part of Ajug community 2001, 2008. Then I got married. I moved away a little bit more farther up north, and Ajug became a distant possibility for me to join in. But thank you for coming over here today, and we'll be talking about a bit of blockchain. The company that I am currently with is Income, and Income is a founder-led company, one of the top 20s in Georgia from a revenue standpoint. I believe there's some recent stats that came out. Very innovative. You probably know us better by our work. So if you have gotten a gift card, I would say go out and take a look at your wallet. You will generally find about 7 out of the 10 gift cards will be an Income provided gift cards. They are generally branded, so you don't see Income. So what we are going to talk tonight, when I was coming up for this particular presentation, I was looking at how much amount of information is actually available on the net, right? There are about 75 million videos on blockchain, about 250 million plus articles that are there available on blockchain and Bitcoin and smart contracts. So really, there's not a whole lot of things that I can tell you guys is really new. What I did find out is in pretty much TED Talks or even very recently, I think there was something in DevNexus that was talking about the trending technologies. People will come up and say, hey, this is blockchain and it can do stuff, and then they'll move on to the next trending technology. So what I really wanted to do today was talk about the very, very basics of the crypto, some history around how does this whole movement of the innovation around blockchain starts. Talk about the Bitcoin blockchain. We are not talking about finances or cryptocurrency there, but actually understanding the Bitcoin blockchain. Go over to how Ethereum modifies this. Then come down to the Hyperledger fabric, where you are going to only see the Java implementation and the other areas of blockchain that are being done there. So, if you know this, this is pretty straightforward. This is a hash function. This is a SHA-256. I take a thank you Ajug. Nothing interesting here. I change the T and nothing interesting here, right? This has been out there since 1950s, and all it can guarantee you to do is when you create a hash function is you can take a string and you can create a hash out of this particular thing. You can pretty much do it any which way. The algorithms that are out there allow you to ensure that the input that you give it, like thank you Ajug, produces an output that is not going to be close to this second input that you give. All you're doing here is putting a little lowercase t. This is called the avalanche effect. You mix this particular hash function with a digital signature algorithm, which is, there are two algorithms out there, DSA and RSA algorithms, if you were to consider the public key, private key cryptography. And what you are going to end up getting is a digital signature. So this is a pretty important concept when you start understanding the blockchain. Second thing is these hash functions in the digital signature algorithm specifically was built out by Diffie-Hellman. And along with Diffie-Hellman, there was a third person recognized for the work that was done. It was Professor Ralph Merkle. And Ralph Merkle had proposed this tree. And this tree is all it guarantees you to do is it creates an immutable and a verifiable record. It's immutable because if you look at this particular diagram, you take a red and a yellow block and you come with an orange block, right? Just imagine 2 hashes, you come up with a third hash. You take the blue and the green and you come up with a green, and then you finally come down here, right? If anyone were to try and change this, one small change will cascade and the results will never match. If you want to go in the back direction, it's very easy to verify. But if you were to change it in this direction, it's pretty hard for you because you'll have to start calculating all the hash nodes. Second part of it is something I learned here in Ajug many years ago. This was about the public key cryptography. This is the going in the front direction where you use the public key to encrypt your message and private key to decrypt your message. So It is very straightforward thing. You take two numbers P and Q, which are prime numbers. You have a D and a E. E allows you to encrypt the message, and D allows you to decrypt the message. Nothing special about this, right? But just remember, this joke has not changed from many years. There is the cryptographer's imagination that somebody is going to try and break your crypto wallets. The reality is somebody is going to buy a $5 wrench and try to get this private key out of you is going to be probably a lot more easier for them. I think the only thing that has changed from the time when I last time heard this explanation is this $5 wrench has become like a $15 wrench from Home Depot. So rest of the things remain the same, right? Coming over, let's define what exactly a contract is, okay? And this is going to be a little bit of my homage to the crypto anarchists that actually led the whole Bitcoin blockchain movement. So you start off with a contract. Contract is simply a promise. So let's imagine how this contract gets formed. There's a small community of people. You want to exchange something, you come up with a barter system, right? After the barter system, at some point in time, you step in and you realize that, hey, I don't have this good to give it to you. Instead of the good, I'm going to give you a promise. A promise becomes a contract. This particular contract eventually will, you will try to renege, or something happens, or somebody doesn't remember the accurate terms of the contract. You are going to end up creating a ledger. This ledger will require some sort of governance, right? And people, the kings and the monarchs that end up managing these ledgers, they would eventually come up with some form of a currency, or some sort of a token. It could be shares, it could be paper money, it could be gold, whatever else it is, right? Eventually leading to the formation of currency, which leads to the formation of fiat currency when that particular object that is being distributed is not good enough, you don't have enough sufficient quantity of it, you will try to create the fiat currency. And this is the cycle that repeats again and again. In 2008, the atmosphere or the environment is right for starting to build up the crypto fiat currencies, right? This is the time when the whole financial crisis happens, and somebody comes up and says, hey, you know what, these fiat currencies are not good enough. US is going to print some additional dollars. So let's try to do something additional, right? This is the backdrop, this is the story that gets told over and over again. I think there are other things that are happening at this point in time. Distributed computing is becoming very easy. Cloud computing, Amazon is starting to take off. People are starting to understand the whole cryptography framework that we were talking about earlier, right? So cryptocurrencies start to form, and then what people realize, what cryptocurrency really solves is the ledger part of the equation, which is what ends up giving the rise to the public smart contracts. So people say, hey, if you could have created a crypto fiat currency, could you have not created a ledger which starts recording these contracts? And smart contracts are not very smart if you get down into the details of it, but they are promises that are self-executing, right? They will always return a deterministic result. That's the whole idea behind it. And blockchain is the technology where you can record it because you're creating a verifiable and immutable ledger. So that's the creation of the public smart contracts. And there are issues found out along the way. And enterprises really want to run and create these smart contracts faster and faster. So is the evolution of smart contracts. And this is the three areas that we will be talking about. And as far as these images are concerned, these are just simply different types of currency notes that were created. You can go into Wikipedia, you'll find a lot of other different types of currencies. Ledgers have been in time immemorial. The cuneiform tablets, going and forming the ledgers, going and forming our databases, going and forming our cloud databases. All of these things have something in common. They are easily corruptible. Somebody can tear out pages, somebody can rewrite the ledgers. All the way down to our current databases. We have a read, write, update access to our databases. If anybody wants to challenge this, I would say if your system of record, give to your peers the access to your system of records to directly update and edit the database, and you will see what kind of mayhem they can bring to your system. They're not easily shareable. Even though we have reached the cloud, you will never be able to take your entire database and hand it over. You have got your batch files running in the middle of the night. That's just for making sure that you take a very specific snapshot of the record and share it with somebody else, right? So these are the current classic problems with the ledgers that exist as of today. And finally, one of the other problems that comes up with the ledgering-based system is somebody who talks about, so somebody who is there on your ledger and says, hey, Eve, I've got $100 with me, right? and they try to spend this money with Alice and Bob, and they decide to send $60 to Alice and $50 with Bob, and you have got a timing attack to do. Right? In this scenario, the market solutions currently in place are trusted authority. This is your US government or your government who is going to make sure that this person is not able to do something like this. This will be your bank, right? Delayed settlement process. You have seen a natural processing. This is almost a 3-day delay processing that happens between interbanks. You have got penalties in place, and you have got indemnification. Finally, if you guys are in the e-commerce space, what you realize is roughly about 20% of the transactions are in that category of fraud, where you can't collect the dollars, right? And this all happens because of the double spending problem that is currently present and prevailing in the system. This is why many of the e-commerce, like many of the people start looking into this area and say, hey, with usage of Bitcoin, I could actually go faster when it comes to settlement part. Okay? So, what happens roughly around 2008? The creation of Bitcoin. But before the creation of Bitcoin, there are actually two more significant events that happened. One of the events is around 92 and then 97. There is this whole concept of Hashcash that gets created. Adam Black publishes his first paper around Hashcash around 97, and there is some amount of work that is done in 92. The whole idea was there, that he was trying to solve is ensuring that spam mails do not occur. Okay, and the idea behind Hashcash is proof of work technology that gets created, but nobody still is able to use it to convert it into something like a Bitcoin. The other thing is around 99, there is a paper, and I might be slightly off from a date standpoint, but 99 there is a paper from Wei somebody about V-Money. And these two papers together influence an organization by the name of Satoshi Nakamoto to create the Bitcoin's white paper. 2008 is a Bitcoin white paper that's published. 2009 is the first blockchain block created. The block has this message in this blockchain, the times 03, chancellor on brink of second bailout, right? It's clearly an indication to the whole bailout process, right? But 2003, 2009 is when the Bitcoin blockchain starts. Nobody talks about blockchain actually. What you're seeing in the behind in the graph is actually the word blockchain picked up from Google Trends, okay? So if you look at it from 2008 to 2012, nobody is really talking about it. The word blockchain does not enter into our global consciousness or Google consciousness. Around 2012, there is Ripple, which is talking a different implementation of blockchain using cross-border payments. Around 2013, 2014 time is Ethereum starting to bring up. There is a white paper written by Vitalik Buterin, yellow paper, and followed by a white paper. And then finally, you start seeing a lot more companies like R3, Hyperledger, and there are a whole lot of interest that comes up. So this part of the story, I would believe most of the folks have heard. But the question is, how do you bring up this blockchain, right? What is the Bitcoin, the core concept? So when you bring up the Bitcoin software, you can go to GitHub, you can download the Bitcoin software. It's gonna start up on your machine. It's a C++ written software, so nothing to do with Java over there. But when you start up, you're gonna become part of this global network. This is a couple of days old. This is taken from bitnodes.com. But you will bring up your node. Your node can come up in 3 possible forms. You can come up with a full node, you can come up with a light node, and you can come up with a mining node, right? A full node means you're gonna take the entire blockchain that has been created so far, and you're gonna create a copy of it for yourself. This is the boon and the bane of Hyperledger, sorry, not Hyperledger, but this is the boon and the bane of the blockchain technology, right? You take the entire thing, you become valid, and you can pretty much validate your own transactions. You don't need to go anywhere else. You can become a light node, which is basically you want to remain on the top of this chain because this is all chain transactions. So long as you have enough data to prove the work that you are trying to do, you can become a light node, right? Or you can become a mining node, which is connected to always to a full node. And what this real node is trying to do is trying to put a consensus mechanism in there, trying to do this proof of work, this Hashcash algorithm that we talked about earlier. There is another type of node or another type of entity in this whole system called wallets. And thing that you have to realize about wallets is there is no such concept as a bank account in Bitcoin. It's purely a ledgering system. So if you do not keep track of your private keys, you don't know what the account value is. Okay, so there are a bunch of wallet softwares created, but they are not really any of these. They are softwares that can be used to keep track of your keys, and you'll see how the keys are actually used in the next slide. So, what does a Bitcoin transaction really looks like? If I try to send some money over to somebody else, this is actually a real transaction. If you guys want to go on the blockchain explorer, the Bitcoin explorers, you should be able to find this particular transaction. But what the transaction really looks like? I am giving this input, and output is the place where the money is going to, right? And if you look at this particular n is equal to, the value is equal to 5.931 and the value is equal to 1678, this is how much amount of money I'm spending in this particular transaction, right? All Bitcoin transactions are spent in full. So whatever is your previous amount of money that was received is the complete money that's going to go out. So the way you spend the money is I find somebody else's public key and I create this scripting challenge for them. And I specify in my transaction the previous guy's challenge, I answer the challenge for the previous guy. So assume that this particular transaction, I send it out to person X. Person X, now the next transaction they end up creating, they have to prove this particular challenge and they will have to create this script signature that you're seeing over here as the next step in the transaction chain. So the in and the out. The interesting thing that you have to keep in mind, two interesting things that you have to keep in mind over here. One is this particular language that you're seeing here, right? Op dupe, op hash 160, op equal verify, op checksum. This is something that actually brings up the creation of Ethereum, or when people start looking at it. This is a very, very basic scripting language that's there. And the other thing you have to keep in mind is blockchain works with something called as UTXO. That means currently whatever transactions are created, they are unspent. The next set of transactions that this thing gets spent, and the next set of transactions again are going to sit in their unspent transaction pool. So if you do not spend the transaction, if you do not fully spend the transaction, you are going to leave. Let's say you had total of 1,678 plus whatever the $5, it ends up being like 184 or something like that. If you don't spend that transaction, that remaining money is collected by the miner as a transaction fee. This is the incentive for the miner to use or to prioritize your transaction over everything else. And that's pretty much it. So you take this transaction, you package it together, and you advertise it to your nodes nearby and say, hey guys, this is a transaction I'm willing to spend. Next, what happens with this particular transaction is it gets sent over to, eventually it will reach to some full node. And in the full node, in the mempool, your transaction is going to sit. And in the main job of the full node is going to be really first to order the transactions. They're going to take these transactions out of the transaction pool and say, hey, which ones do I really want to pick up? They are going to put these together in the Merkle tree. If you remember the Merkle tree previously from the first slide. So they're going to put these transactions together in a Merkle tree. Add the first transaction once this Merkle tree has been created as the Coinbase, and all the transactions, the fees that have been left out are going to be calculated together, and that's going to end up being the first transaction that comes up. Now, the block gets published, and the whole thing is you need to calculate this nonce value. And this is where the proof of work comes in, right? There is a difficulty target that's given to the block. This target is calculated every 216 blocks. So the idea is you're going to create the entire Merkle tree from all the transactions. You're going to add your Coinbase transaction and then calculate this nonce. And once you publish this particular transaction, everybody else in the network is going to basically take a look at this transaction, this particular block, and get it added to the current blockchain. It also means at this point in time, the people, if they have been working on the current block, once they see this new block, they can verify it, they're going to drop their work and they're going to restart. Okay? So This also is, if you have seen some of the documentaries around blockchains, like, hey, Bitcoin is wasting a whole lot of energy. This is the place where the energy wastage is coming. Because imagine everybody gets together, everybody gets these transactions in their pool, they start calculating the next block, they don't win, and now they drop their current work and they pick up the next one and they start working on it to build the next block, right? This calculation of the nonce value is simply governed by 3 parameters. You take the previous block's hash, you add the Merkle root, this is your transactions all added together in a Merkle tree. And then you start with this nonce value. This nonce value is nothing, it's just a nonsense value. It starts off with 1, 2, 3, 4. You can take any random value. What's guaranteed is when you try to use SHA-256 and try to build that hash, it needs to be below the difficulty target. And what's guaranteed is every 216 blocks, that target is adjusted by the miners together to bring it down so that always your calculation ends up being 10 minutes long. Okay? This is what guarantees that a block is being created in every 10 minutes. There are other consensus algorithms other than proof of work. This particular algorithm is called proof of work. There is a proof of stake which basically says, hey, who gets the rights for doing mining? You basically lock up your bitcoins or your ETHs into some sort of escrow account, and then you can get a right for voting and being part of your mining operation. There is another algorithm like practical Byzantine fault tolerance system. This is more becoming prevalent in the private blockchains. This one does not scale very well when it comes to higher number of nodes, but it works perfectly fine if you're in a smaller environment. And this is not really, most of these algorithms are not really created for the blockchain technology itself. They've just been there, and now people are finding uses of these consensus algorithms. So, you have got your block, you have published your block, what happens, right? In the network, if you look at it, there are folks that can end up happening. So imagine 3 people coming together saying, hey, you know what, this is my next block. There are a lot of people who can solve this particular block in 10 minutes time. The length of the block defines the blockchain. So here, if you look at this example, if node A, B, and C had picked up the block 4 and they all agreed to come up with block 5 with their own work, whereas node D created the block 5 out of block 4 and it has got all of these guys together in his network, and they are saying, hey, you know what, this is the right block to go with, and they end up creating the block number 6 and block number 7, this chain from 1, 2, 3, 4, 5, 6, 7 becomes the longest chain. This also means this block 5 becomes an orphan block. Okay, and this happens pretty frequently in the Bitcoin world. These forks are called soft forks. They happen, they merge, and not everybody gets the coin-based transaction, the transaction fee. Somebody else gets it, right? But this is just being fair to the overall Bitcoin ecosystem. There are other things that can happen. These are called the hard forks. These are bad things that happen. This is the time where somebody decides that they're going to change the protocol. They're going to start using a different version, something different about the blockchain, right? When a hard fork occurs at that point in time, these transactions are going on a different track. If they ever were to merge together in the previous block, if they can ever merge, I mean, basically all the transactions here are lost. Okay, so hard forks are generally not to have, and then user-activated forks. These are soft forks that are designed in such a way, once you get 51% of the network together, somebody can flip the switch and say, you know what, remaining 49% people follow me, right? So these are another type of forks that you end up seeing. So in summary, when you look at Bitcoins is not a smart contract platform, but it's important for you to understand the basic blockchain implementation, the simplest one that you can actually understand. Java can be used to integrate with Bitcoins. If you really want to use Java and Bitcoins together, I think your best bet is going to be something like Coinbase, or you can use something like Bitcoin J. It's a wallet technology. That's pretty much the extent of which you can go. And if you really want to write smart contracts with Bitcoins, remember that one of the slides I'd shown you, the first block had some message in there entered by Satoshi Nakamoto. That particular message is good enough space. I think it's about 80 bytes of data. If you really wanted to tweak this blockchain technology under Bitcoins, you can use it. And there are some people who are trying to tinker and create some smart contracts out of Bitcoins. But this is not the technology that you want to be interested in if you're really looking at smart contracts. So, going over to Ethereum, somewhere around 2012, 2013, I think so, there was a big question around, hey, Bitcoin's it's not dying, it's still evolving. What exactly can we do with this particular technology? And people started looking at the script signature, the one that I was showing you earlier. And they said, hey, if we could expand the script signature, if we can create a Turing complete machine, if we can add some more things like, can I add a jump or a call to the entire stack? Would it not be cool for me? Because then I can start writing complete contracts, complete executable states. So Ethereum improvises on that and it creates this Turing complete EVM. Beyond creating the Turing complete EVM, they also have to solve now for state. So the blockchain was pretty cool. You have got all your blocks together, you have got your transactions together. Now you somehow have to manage the state and keep this on the blockchain. Ethereum solves for that, and we'll take a look at how it solves for it. They also realize that transaction fees are a problem, right? There is this coin-based transaction and the transaction fees. They decide that, hey, you know what, if you want to spend these Bitcoins in partials instead of full, we could replace the whole concept of money and we go down a completely different route. All we have got to figure out is how we pay for the compute power that we are going to end up using in this global computer. So they replace the transaction fee with gas. The currency that is designed in Ethereum, the ETH, does not have an upper limit. In Bitcoin's blockchain, the Bitcoin is limited to, I think, about 21, 22 million Bitcoins that can ever be mined. The smallest unit of Bitcoin is called Satoshi, it's 10 raised to 8, whereas over here, what's created is 10 raised to 18, which is called a Wei, and the currency really has got no upper limit. It keeps on, it just controls the amount of ether that can get created for every transaction. Block time is reduced in this, and this raises a very interesting problem for the community. Instead of going for a 10-minute block time, they go for a 17-second block time. And this means that you got lesser wasted effort, you get your results quicker, people can go to the next block quicker, but it has some really interesting consequences. And then the whole model of unspent transaction output, which guarantees you anonymity, it's pretty hard for you to really trace these transactions back in Bitcoin. It gets changed into something like an account, right? So in Ethereum, you have got an account state. So for you to make a state management or a state machine, you need to know who is going from what state to what state. So basically, accounts are replace the UTXO model of the Bitcoin. Now, how do you pay for this particular machine, and what happens in the Ethereum blockchain is, if you look at it over here, the gas prices, right? This is actually published something in the white paper. It's just a simplified explanation of the gas prices. Every single instruction that gets executed by the Ethereum virtual machine, there is a price associated with it. The price is associated as a gas value, right? So if you want to do an add, it's going to cost you 3 gas, right? When you want to send this transaction into an Ethereum machine, you are going to say, hey, I want to spend 3 gas, and I say the gas price is going to be X. And the thing that gas really does for Ethereum is, if you wanted to run an endless loop, it can block you from doing that, right? You don't have endless amount of money, you've got only a certain number of ether, and you are going to basically provide a denial of service for the EVM. And it gives everybody a fair chance of using the virtual machine. Also, the second concept that get introduced is accounts. The accounts are 2 types of accounts here. So you have got your externally owned accounts, that's something you and I can own. And then you have got the smart contract accounts. These are accounts that live within the Ethereum VM. So every time you create your smart contract, you send it in. The copy of the smart contract is something that's there with all the peer nodes for the EVM. And the externally owned accounts are something that is there with you, but the balances are maintained for these accounts over here. You join a couple of these accounts together and you can come up with a decentralized autonomous organization. That's like the big sell for Ethereum, why Ethereum becomes very important. So let's take a look at this. This is a little bit of an eyeful, but now remember the simplified version of Bitcoin's blockchain. This is the Ethereum's block construction. So you still have the parent hash, you still have the difficulty, you still have the nonce value, you still have the timestamp. Some of these things are very much still here, right? There's an introduction of gas limit. This is the limit that you cannot go over when you're creating the block. There is Amr's hash. with the use of Omar hash, Ethereum's blockchain almost becomes like a DAG, a kind of a structure which is a blockchain, which is also taking all these orphan hashes. Remember previously I had said that the time got changed from 10 minutes to 16 seconds. That particular approach ends up creating a lot of orphans in case of Ethereum. So now to incentivize the miners, they create this Omar hash, which is basically a tree of these orphans together. You can take the orphans from the previous blocks and say, okay, fine, you guys can also come along for the ride and we'll join you together in the main block. The other one here is a state root. This is the place where all the state of every single account gets stored. The actual hash value for the state is stored in the Ethereum, but the actual state is not stored within the Ethereum's main blockchain. So if you look at Ethereum, you will see the blockchain is roughly about the size of 200 gigs or so at this point in time, but the total Ethereum database is roughly about a terabyte the last I checked. And the reason for that is this whole account state is getting stored in a separate database, which can be calculated if you walk through the entire transaction chain. The transaction route is what you are sending into your smart contract, and the receipt route is if your transaction got executed, what happens if your transaction gets does not complete, you did not provide enough amount of gas to your transaction and it fails, or it succeeds. So all of that thing comes in the receipt route for keeping the track of the receipt, right? And just for as part of the Merkle tree implementation of Ethereum goes, it's changed into a Patricia Merkle tree algorithm, which is basically a short way of saying, hey, create this Merkle tree instead of just creating a binary tree kind of a structure. Let's create one that has got multiple nodes, and you can compress this much more easily so that you can save a lot of disk space instead of the regular Merkle tree implementation. So now just let's take a look at a little bit of code. This particular code is available for on the net. This is part of the code. This is greater or solved. So what exactly ends up happening? So for Ethereum, you are actually using the EVM bytecode that you have to compile. This is a language called Solidity, which is a higher level language for you to write your code in, and then you can compile it using SolC. SolC is going to give you Ethereum virtual machine bytecode equivalent, and it's also going to give you an ABI, an application binary interface. You use the ABI, and then you can use a library like Web3j, and you can convert your Solidity code into a Java, almost to the effect of, if you guys remember back in the days, EJBC, you have your contracts defined, you use EJBC to compile your code. This is going pretty much in the same route, and you will end up creating a simple Java-like construct here. And if you have been following what I said previously around the gas and everything else, here is the gas price, gas limit. You load your credentials from the wallet. This is your own account where you have got the ethers to spend for this particular transaction. You deploy this transaction using this particular command. And since this one is just going to print an output, this is not going to cost you any additional gas. But here, if you look at it, this is the place where you'll be able to get get your output, the hello world of Ethereum. Keep in mind, this is purely a wrapper around the actual smart contract. The smart contract in Ethereum is being written in EVM bytecode. If you know how to read the EVM bytecode, better for you. Otherwise, you can use higher level languages like Solidity or Viper or Serpent. There are a bunch of other ones. So what happens here in Ethereum? Ethereum becomes a little bit more interesting. Ethereum, you have got Geth. Geth is, for some reason, Go seems to be the preferred language of blockchain, whether it comes to Hyperledger or it comes to Ethereum. So Geth is one of your clients that you can download. It's very similar to the Bitcoin Core. You get the Geth client. You take your code and you try to send your code through this bridge over to your current node. Your current node is going to end up getting your contracts down to the mining node. The mining nodes, there could be multiple mining nodes. There could be limits that can be imposed by the mining nodes. Where people will say, hey, you know what? If you are below a certain gas limit, I don't want to deal with this particular smart contract. If you're above the gas limit, great. I'm going to make you part of my chain. I'm going to collect all the revenue from there, and I'm going to execute the contract. right? And then the block gas limit is something that the miners have to keep in mind. They cannot spend more than a certain amount of gas for creating the transaction, because that's what is controlled by the main block. The block is going to get rejected. So net of what happens in Ethereum. Again, Java can be used to call a smart contract, but Ethereum's bytecode is not Java. dApps, the distributed applications that people are talking about on Ethereum, they mostly favor JavaScript over Java. So the whole model that you're looking at Ethereum is probably getting a plugin in your Chrome browser and then just directly using it to connect with the Ethereum blockchain and just using it from there on out. But if you want to really use Java, you can definitely use Java in case of Ethereum. And there are some other projects in Hyperledger like Besu, and there's one more, Burrow, which you can use for creation of some Java-like constructs in Ethereum. Now comes the enterprise, right? Enterprise has been sitting on the back. If you have been following the Ethereum story, it's almost like a movie unfolding. Folks are looking at this and they'll realize that, hey, we have got use cases like supply chain, healthcare. There are a bunch of other markets that have got real use cases for blockchain technology, but they do not want to spend. They have got certain other criteria to take a look at, right? So blockchain is guaranteed, right? Guarantee is immutable and verifiable record keeping, that's great. Resources. On a public blockchain, I got to execute on public infrastructure. Resources are unoptimized at that point in time. Whereas in case of private, I would execute within the private infrastructure. I would want to make sure I'm making the best use of my resources, right? Consensus and ordering. In the case of a public blockchain, there is really a TNO kind of a policy, trust no one, where proof is required, right? This is where most of the miners are spending their time. In the private blockchain, it's a very, very trusted, it's a small network of people who can really participate in the blockchain. Incentivization, if you look at the previous blockchains like Bitcoin and Ethereum, and you can name it some of the other ones, you're gonna say they are required pretty much to mitigate the tragedy of the commons. That's basically, if you have got this great resource that you can use, what stops you from abusing this resource, right? There has to be some sort of incentivization that needs to happen over here. In the case of private, it's optional. Safeguarding is by the organizational interest. Permissions, here, if you want to become part of the public blockchain like Ethereum or Bitcoins, it's not really required. I can just download the Bitcoin core and I can just start mining away at this point in time. For the private blockchain, we need to control this particular thing because, again, of the property that we have chosen. And then contract privacy, in the case of a public blockchain, it's out there in the open. If somebody can really decompile your code, it's going to be right there. On the private blockchains, this is more of a need-to-know basis. So the Hyperledger project comes along, and Hyperledger is more of a consortium, more of a community than a project by itself. It's like the Linux Foundation, actually part of the Linux Foundation. And what it is only giving them people as the legal framework. There are a bunch of other projects that are in the Hyperledger community. There is Besus, there is Burrow, which are basically EVM, Ethereum's counterparts using Java. So there is some work that's being done. There is Hyperledger Fabric, which we'll go a little bit more into detail in. There's Hyperledger Sawtooth, Iroha, which is the C++ implementation of Hyperledger. There is Indy, which is around identity management and stuff. And then down here below, if you look at it, you have got Toolbox, which is, you have got Cello, which is blockchain as a service. There is Hyperledger Explorer. If you want to start looking at your blockchain, this is going to be a project of interest for you. Caliper, this is a performance measurement kind of a project. And then Hyperledger Composer, this was something that I originally intended to use for building the demo. It's pretty quick to build demos on Composer, but they actually deprecated it down in somewhere in May, June timeframe this year. And the reason they deprecated it is it seemed to have become very specific to Fabric, and it was losing the, it was more geared towards business for you to build out the business network, but it was actually losing some of the properties that was going on from the actual implementation. So, what really changes in Fabric's network, right? When you start now taking up the Hyperledger Fabric and start building up your blockchain, what really changes is you got to have few nodes. So you got an endorsing peer, you got an ordering peer, and you got a committer peer, right? The same thing that was happening previously, ordering and endorsing in the mining nodes of the Bitcoin and the Ethereum blockchain, that has been now put out in open. You basically say, hey, you know what? First, you get the endorsement done, which is basically make sure that this smart contract is going to execute correctly and what the output is. Then you send it over to an ordering peer. This is the guy who's going to basically make sure that the transactions are put in the right order, which was being done all as the full nodes implementation in Bitcoin. And then you've got the committing peer, which is that everybody is going to take this particular transaction that has been ordered and going to put it in their blockchain. I believe this is, before we just jump into a quick demo, this is the final slide. So what a transaction flow really looks like, you take a client SDK, you send a transaction proposal to these endorsing peer. The endorsing peer is going to send back an endorsed transaction. Endorsed transaction, the client application has to send this endorsed transaction over to the ordering service. That goes to the committing, and then it gets back to the client. If you look at this particular implementation of blockchain, it becomes much simpler. They are only standing here at the top. The number, the previous hash, the data hash, right? This part of it is the initial transaction proposal, endorsement, and the proposal response, and that's pretty much it, right? But I mind you, I say this thing, the Fabric's implementation of blockchain is a little bit more cumbersome, and the implementation will be best if you start off with a sample example. And that's what I'm going to just run here real quick. Part of my setup or the instructions that were there is really, it's within the Fabric's GitHub repos. And the network is called the first network. You install Docker, you get the Docker image, you clone the examples, and then you run the network for yourself, right? And let's just take a look at this network. Let me see. This is the tough, okay. If I put it up here, I'm assuming you can see it. Right, okay, let's see. Okay. I hope you guys can read it. If you cannot, please let me know. I'll increase the
Switch, turn off the light. Yeah, the lights. The light.
Okay. Let me see if I can change. Okay.
Yeah, thank you.
Better?
Yep.
Okay. So you will end up being somewhere in this first network directly once you have created your downloaded your.
Make the font bigger. Command plus.
It's Control Plus. So.
Maximize the screen. Yeah, green.
Well, no, if he does that, the resolution never.
That's fine.
There you go, keep going.
No, it's always cutting something off.
Oh, you're right.
Yeah.
Let's see.
That works.
You guys can see?
Yeah.
Make it bigger. Command plus.
More?
More.
Okay.
Cut again.
Now I'm not quite sure what else is we are going to be able to read, but let's see.
There we can see the
Visible?
Yes.
Okay, let me just make sure I have the, okay, this is good enough. So basically you're going to end up being in this directory where your first network code is downloaded, right? And what you're going to end up doing is, once you have downloaded all your Dockers and all the images, etc., if you were to take a look at Docker images, I think, oh, there are a whole bunch of them. Probably want to look at one. This is the one that you are probably interested in from a Docker standpoint. And what you are going to end up doing is something like this, sh sh minus l. You're trying to bring up the first network. And while it starts up, we will come back to this result. I just want to represent this back on the screen if this thing comes up. Okay, so what we are trying to bring up here is two organizations together, which have got two peers on them, and then there is an ordering service sitting in the middle that's going to take care of ordering the transaction. It's an account-based example, so it's basically going to start off with like 100 being present on both account A and account B, and then it's going to transfer 10 from account A to account B. Fairly straightforward thing. So, could help if I can see myself. Good. So the interesting pieces of this entire execution, and again guys, I don't know if you guys can see this.
We can when you
Hover
highlight it.
over there. Okay. So the interesting thing is the entire definition of the network that I showed you in the previous slide is right here in this config tx.yaml. This is what's helping it build it. There is a Docker Compose file over here which is actually bringing up multiple nodes, multiple VMs, and bringing up the entire organization. The organization is running two peers, one order, right? Then ordering, the service that we are ending up using here is Solo. Solo is not really meant for production, but this is the simplest ordering service that's available for you. You end up creating your channel, and somewhere around here, you'll see that the Docker Compose kicks in and it brings up all your peers together. Your channel is created, your order is created, your peers are asked to join the channel, and then okay, right here, you install your Java code, which is sitting in one of your Java directories on the Java interface, and then you instantiate the Java code, which is where you are setting A as 100 and B as 200, and then after that you can query the channel. So you can run this particular command and say here query channel query is equal to A. It gives you the value of 100. You try to execute a transaction, invoke A and B, and then you get the answer 10. And that's pretty much it from a demo standpoint, right? So if you were to take a look at closer look at this particular code, you want let's try this. Chain code. Okay, so this is your code that is getting installed. This is in your CLI interface, and when you saw that install command is picking it up from that, deploying it in one of your nodes, and it's running it, right? The only interesting part that I would say that the main part is here in this is where the state changes here, right? So see this? This is what is really different. This is what is actually adding stuff onto the state of the blockchain ledger. The rest of it is pretty much a standard Java code. You're gonna basically take a look at it from your response. This is your init. So here the two values are being set. You're writing your regular log statements, etc. If you want, you can really debug that from that standpoint. And this is your invoke method, the one that we invoked to transfer the funds. Conditions, then that's pretty much it from the Java code standpoint. Now the code that you're going to see in smart contract, I initially said that smart contracts are not really smart. It's going to be very basic, but you have to understand that the compute that you're using here is purely geared towards verification and immutability more than running like a crazy multi-threaded code and things like that, right? But you could now within this particular JVM, you could run whatever else you wanted to run, whereas in the case of the Ethereum's EVM, you are probably going to get limited down to a very specific set of EVM bytecode that you can really use. The other thing that you would want to look at is if you were to that makes it more readable. So if you look at it, these are the containers that we were talking about earlier. Pretty much everything goes out. But here, if you look at it, these are the two nodes that got started on organization 1. These are the two nodes on organization 2. And these nodes, some of them have the policy to install and invoke the chain code for themselves. This is where the chain code is getting started. So if you look at the other peers that are getting started, this is really where the Java code is being run for this. Now, once you understand this piece of it, I'm sure you can go ahead and start playing around with the FabCar example or start modifying this particular piece of code and move forward from there. So that was pretty much it, guys. Wrapping it all up. In summary, Bitcoin is a simplified or the simplest blockchain if you understand it well. The rest of the blockchains that you're seeing in Ethereum, Hyperledger, etc., are really plays on trying to improvise on the main blockchain, whether it's going to be around the speed or the size of the blockchain and a whole bunch of other things. Ethereum uses a very domain-specific language. The most I would say that the reason why they would not have chosen Java or a more complete language like Java is they really want to open this thing out into public, and you want the contracts to remain deterministic. So you have to constrain a whole lot of additional what Java can really bring to the table, right? The additional libraries and features and stuff like that. They want to constrain it so it does not run away into creating something completely different. And Ethereum has had its issues in the past, even with the simplest Ethereum virtual machine or the Ethereum bytecode that has got. If anybody knows the DAO hack, it was one of the most interesting ones. It's amazing that you can, even with such a limited language, you can still hack. And it was roughly about, I think, about $60 million that were lost, or it eventually ended up creating the ERC20 part of Ethereum.
Was that the one that did they recover from that with a hard fork?
Yes. So that's where you will see Ethereum Classic and Ethereum ERC20 unit. That's the reason literally what happens, and it becomes a classic case where people say that, hey, you know what, this blockchain is immutable. The blockchain is you can't change it, but then you can change it if you have got consensus of over 51% of the folks. So that was a very interesting one. If you guys have not really read about it, I would definitely say the folks who are interested in the blockchain technology, read about the Ethereum. There's another one around the multi-sig wallet. Both of them are pretty substantial from a cost standpoint, right? So the dollar value, the dollar impacts are really real here. And the final one is the Hyperledger Fabric. It's a complete custom. It's almost like IKEA of blockchain technology or the smart contracts technology. You can actually build whatever you really want to, but you have to be a little bit more careful when you start playing around with it. And it's a little bit more set up than Ethereum and Bitcoin's. Ethereum, you can still start off your private networks. Ethereum also, you can use it in the private enterprises using a blockchain on top of it called Quorum that is built on top of Ethereum. So there are use cases for Ethereum also in the private enterprise. But I would say Fabric should be a way to go. There is another technology called R3 Corda. That's also, if you are really a hardcore Java, that's like literally dealing with Java a lot more than Hyperledger Fabric, which almost started with Go. So that's pretty much it, guys. Thank you. Thank you very much.
Questions?
Good.
So can you speak a little more towards talking about its applications in enterprise and things like that? Why would you choose a blockchain solution over a traditional database ledger and just deal with the pain and the cost of shipping that around?
Good question. So the place where you will start seeing the use of blockchain come up is really around enterprise, cross-enterprise transactions, right? Within an enterprise, the trust level is so high that I don't think there is going to be a whole lot of use cases within the enterprise. But supply chain, right? Walmart, I believe it was Walmart, if I'm not wrong. Walmart with IBM, I think they implemented the whole soup to nuts from all the way from the grower's farm, all the way getting the vegetables or something like that, all the way up to the stack, right? There is another example out there of a coffee grower, all the way from coffee down to the person's mug, where you simply print the block number and you can go scan that particular block number and you can find that. So generally these solutions where I think so is finding this niche space is really enterprises, where two enterprises are talking to each other, and now how do you share the information? The current method that we have got is pretty much we create one-way ledgering system, right? We create one-way batch files that end up getting created every night. If possible in future, what we can probably look at is these ledgers which are always available to you, nobody can change them, and this is the system of record.
Yeah, to speak to that, sometimes it's multiple one-way because they got to go back and forth.
Yes. So I think that's the place where I would see this technology kind of expanding, and then there is definitely the other use cases that you're seeing in the public space. Folks have talked about replacing Uber, replacing Airbnb. I mean, there are a whole bunch of use cases in the public space. Any other questions, guys?
One more question.
Oh.
So, let's
Yeah.
So we got.
Sorry. Go ahead.
So I read a lot about central banks of developing nations looking into the blockchain for their currency and contracts, and what is the deal with that, and what kind of software do they use, and why specifically would they want to use that in places like Africa?
So that was the place where I was trying to go down to. And again, guys, I am an enthusiast in this space, but this is the crypto anarchist talk that if you look at this slide, this motivational slide of what exactly happens with the fiat currency and currency, right? This is the place where people would like to have trust in the system, right? You have seen, I believe it was Zimbabwe and then Venezuela as of recently, right? Where you end up building a currency, then you end up building a fiat currency, and then you have got the central banks that are really controlling the generation of fiat currency. At the time where the fiat currency goes out of your control, right? You keep on printing, people will lose trust. Eventually they're going to be like, hey, where is the end to this particular thing? When am I going to really get paid back? Because as people generate more and more of this fiat currency, the less and less the people generally have it. There is a person who's actually losing out. So where I think so generally the banks and other folks are really looking at is keeping a check on the other country or the other person. Like central bank's implementation, I believe their interest was in Ethereum or Ripple, I think so. Ripple is the cross-border payments. I mean, I can get you a little bit more detailed answer, but if you go through a couple of some of the podcasts where these bankers are actually coming up and actually talking about their use cases, you are going to see. But generally, it's about trust, about somebody else not giving you the value. So today, the way their trust is being controlled, I think it was whatever the NATO, I'm forgetting the name of the organization, but basically the IMF organization, right? They have currently the US dollars as their currency reserve. They've been talking about, hey, do we really want to keep US dollars as the currency reserve, or do you want to switch it over to something else? What if we start issuing these tokens? What happens? Right? So there's a lot of conversation that's going on around it. You had another question?
Yes, it's more like a basic question. So let's say somebody wants to use a private blockchain, and whom else they can use their blockchain with? Isn't he tied up with isn't the person going to be tied up with the vendor? Or how does one go about, like implementing a blockchain that you said copy to real copy? So what really happens then? Does everybody has to have the same blockchain or same hyperledger to make that a reality? Or it's like more like open thing?
So the last example that I actually went through for the fabric example, right? That it literally talks about that. So think about in this example, if you talk about it, you will have organization one, your organization, right, and my organization. We will all come up together and say, hey, let's start using this Hyperledger fabric together, right? Between us, we will create these ordering service. Right now, for this example, it's much simpler, but ideally, we will have our ordering service here, and we'll have the same set of rules, but we will say, hey, this is the ordering service. You come up with your contract, you install the contracts over here. The endorsement policy is gonna basically govern who can run that particular contract. It's gonna run not just in one organization, but in both organizations. They should be able to produce the same kind of results and run through the ordering service and give you the same output. So yes, and if you really have like 4, 5, 6, 7 different players, it's gonna pretty much be the same. And now just to change it over to something like Ethereum, I mean, you can start off your network right there, and your private contracts, I would not say private contracts, but your contracts can literally start living on top of Ethereum. So only you and I need to use a specific contract on Ethereum. Not everybody doesn't need to really know about it. So long as we have the document, yeah, you can start using even the public blockchains for doing something. Go ahead.
First off, thank you so much for taking time out to come share your thoughts, and also the company for these fantastic sandwiches. They're very awesome. I have a corollary to what he said earlier with regards to, I'm just curious about the tactical implication. Like, when you tactically implement this, you mentioned supply chain, right? For example, today, you had a delta of like maybe 30 degrees, from 40 to 60. You mentioned a lot of processing, cryptographic processing. Can you kind of like, or at least provide like a historical context? Because you say those things, but the durational resilience of it for it to operate, with the database technologies that he mentioned earlier, no one is going to really be angry at you. There's a bastion of places to go. No one is going to be upset, but you're going to have a lot of explanations for like, hey, I decided to use the blockchain.
Why?
Exactly. Like.
So let me caveat that my answer by first saying I am as much as a tech enthusiast as you guys, right? I am not selling any specific blockchain product, right? Having said that, what I also see, I struggle with the same questions like, hey, why exactly would somebody go? And the only answer that really comes back is what I gave my previous answer. It's really going to be if two enterprises trust each other as much as you trust within yourself, right? Within a single organization where you have got complete control, do you trust when you start interacting with another organization? If you do trust, I don't think the blockchain technology is going to really, this is just my personal opinion. I know people will have other different agendas, but I don't think that within an organization that has a high level of trust, you will be able to make a use case for something like blockchain. But somewhere where the trust is low, right? Somewhere where you're going to think, hey, this guy is going to basically take these records and change it, and I'll not come to know about it, that's the place where you want to use the blockchain. Right? That's where I see that most of it is going to end up being used.
It's the intersection of where you want to show somebody else the books, but you also want to make sure that they don't cross out the number.
Exactly. Nobody will be able to change it. Like if you understood the Merkle tree part of it, if you have to change the Merkle tree, the amount of compute, even the Ethereum hack or the hard fork that occurred, it was painful and it was discussed out there in public forums, right? People asked like, hey, do you want to do it? Eventually there were 2 forks created where one set of folks went ahead and said, hey, we are going to start using Ethereum Classic. We do not agree with the decision that has been made by this other half of the community. And there was actually a fork, right? So that would be the thing. Any other questions, guys? Okay. Thank you, guys.